So, for what feels like forever now, the story in AI has been pretty simple. Bigger is better. Bigger models, more data, more computing power. But what if the next giant leap for AI isn't about getting bigger at all? What if it's about getting smarter in a completely different way? Okay, let's get into it.
I mean, you can't escape it, right? We are smack in the middle of the age of these massive large language models. These things are the generalist giants, the brains behind most of the AI agents we see today. They make the big strategic calls and handle all the complex chats. It's a whole system built around one single super powerful brain in the cloud.
But here's the twist, and it's the big question we're diving into today. While all eyes are on these giant models, there's a really powerful counter-trend bubbling up. A trend that suggests for a lot of the most practical, real-world uses, the future of AI might just be smaller, more focused, and way, way more efficient.
All right, so to really get why this is happening, we've got to shift our focus. We need to look away from the digital cloud and down to the concrete world. We're seeing AI start to take physical form, creating a brand new kind of workforce on factory floors and inside sprawling warehouses.
And listen, we are not talking about some tiny niche market here. The projected market for humanoid robots is set to explode, hitting nearly $30 billion by 2036. That is a massive economic wave coming our way, and it's creating this huge demand for a whole new kind of AI to run these machines.
Now, what's really fascinating here is where these robots are showing up first. So you can forget about having a robot butler bring you a drink anytime soon. The first markets that are really taking off are these highly controlled places, like car factories and logistics hubs, where all the tasks are super well-defined and, let's be honest, pretty repetitive.
And what are their day jobs? Well, they're focused on the basics, the scalable stuff, moving parts from here to there, inspecting products for defects, and helping out with simple assembly. For these kinds of jobs, you don't need an AI that can write poetry. You need one that's rock-solid reliable, totally safe, and crazy efficient.
Which brings us to our next big point. If you've got a specialized job, you need a specialized brain, right? Using a massive do-everything LLM to tell a robot to move a box from point A to point B, well, that's like hiring a theoretical physicist just to screw in a light bulb. It is complete and total overkill.
And this table just lays out the trade-off perfectly. LLMs are amazing for a deep conversation or some complex reasoning, but man, they are slow and super expensive to run. On the other hand, you've got small language models, or SLMs. These are your specialists. They're lightning fast, cheap to operate, and you can easily fine-tune them for exactly those kinds of specific, repetitive tasks that these robots do all day long.
This visual shows you the architectural shift that's happening as we speak. On the left, that's the old way. One giant LLM trying to run the whole show. But on the right, that's the future. You've got a smart controller that acts more like a manager, calling on a team of smaller expert models like their specialized tools in a toolbox. It's modular, it's efficient, and it's just a much more practical way to build.
Now, I know what you might be thinking. Okay, smaller is cheaper, I get it, but is it really smart enough? And that's where this story gets really interesting. These small models are making a huge impact because they're getting incredibly capable. Very, very fast.
This quote from a recent NVIDIA paper just hits the nail on the head. It says what really matters isn't just the size of the model, how many billions of parameters it has. What really matters is its capability. Can it actually do the job you need it to do? For a lot of these robotic tasks, the answer is a huge, resounding yes. And hey, this isn't just theory. Just look at this new wave of powerful SLMs hitting the scene. Microsoft's Phi models, for example, can get reasoning and coding scores that are on par with models 10 times their size. NVIDIA's Nimitron H family and these others are demonstrating incredible performance on things like following instructions and using tools, which are absolutely vital for AI agents.
And the economic argument? It's just staggering. Running a small language model can be 10 to 30 times cheaper than running a giant LLM. We're talking about latency, energy, and of course cost. Now imagine you're running a factory with thousands of robots. At that scale, that difference isn't just a saving. It's the one thing that makes your business commercially viable.
And the great thing is there's a clear roadmap for companies to make this transition. You can start by just logging all the interactions your agents are having with a big model. Then you can sift through that data, find the patterns, and identify the most common tasks. From there, you just use that data to fine-tune a small, expert SLM to handle that one task perfectly, efficiently, and cheaply. But this whole conversation about big versus small is actually pointing to an even more profound shift in how AI might work in the future. It's about building an AI with a fundamentally different kind of intelligence.
This is a concept called neuro-symbolic AI. Now, it sounds complex, but think of it this way. Today's AI is mostly neural. It's brilliant at finding patterns in huge piles of data, but it's missing the symbolic reasoning, that deep understanding of rules, logic, and how the world actually works. Combining those two, well, that's the path towards an AI with something that looks a lot like genuine common sense.
And as researchers at IBM put it, this isn't just the next small step. This is a fundamental change, a revolution. It's about moving away from models that are just incredible pattern matchers to models that can actually reason about the world in a way that feels much more human.
So where does this all leave us? The shift from big, generalist models to small, specialized ones is just the beginning. The real destination, the real turning point we're headed towards, is an AI that combines the pattern recognition of today with true logical reasoning. And that begs the question, what happens then? What new possibilities get unlocked when AI can learn not just from data, but with a deep understanding of the world itself? That's the future we're building.